Okay, now I gave you these nuggets of advice. If you're somehow keeping track of these, they still are legit. Like, these nuggets of advice will always be true. Changing everything to sines and cosines, factoring, and then we have this idea of looking for squares. Okay, I'm going to keep showing you that stuff. Fractions, though, fractions is basically the main event today. And if you're writing down these little nuggets of advice, we basically have kind of like 3 ways that you can handle a fraction. You can simplify it, you can use a heart method, or maybe it's going to need a common denominator. Now, what I find for kids is not just being able to say these 3 words to me. I know you can say simplify, you can say heart method, you can say common denominator, but it's understanding when to use them. It's understanding when to use them. And of course, most of the time with math, it's best learned by some examples. Okay, so I'm going to really sort of carefully go through each of these situations with you. This fraction, when you're ready, it's cosine over sine times cotangent squared. Cosine over sine times cotangent squared. Okay, this is a trig expression. It needs simplified. Even if you say, nah, Miss Naylor, that's good. It looks good to me. It's fine, but it can become simpler. And we want you to learn this major concept. This is a major part of trigonometry that you're in right now. Listen, common denominator. It actually is usually the easiest one to either decide yes or no. Okay, because the only time you're going to need a common denominator is if you're trying to add or subtract 2 fractions. Pretty obvious, right? We're not adding or subtracting 2 fractions. So we don't need to even think about that. Now, the heart method is also usually a little easier to understand because it's going to be a situation where you literally can draw a heart. And we know the shape of a heart, at least when it's kind of right side up, has to be like this. Okay, basically that signifies that there's one thing in the bottom and there's 2 items in the top. And they would also have to be added or subtracted. It just doesn't have that look. I can't circle something and try to make it like a heart here. Okay, because I don't have one thing in the bottom and 2 items in the top. Now, sometimes students will accidentally be tempted to use like an upside down heart method. You know, we'll do something like this, but there's no such thing. Okay, so in a situation like this problem, it actually just falls into simplify. Now, simplify is a pretty generic word, but basically simplify means that we can take what we have and we can kind of put it together, we can cancel it, and that's, of course, what I want to show you. Okay, now, to show you this, I want you to realize that you are allowed to, as I say, put these items together. And sometimes kids are like, so I can just put those 2 together? Yeah, I can put together any combination I want. Now, the reason I'm putting those 2 together is because they equal an identity. Now, I don't know how much you've read your little book, if you haven't looked at it since last week. If you look in your little book, cosine over sine is equal to cotangent. Okay, cosine over sine is equal to cotangent. So I'm taking that yellow arrangement and I'm turning it into cotangent. Now I want you to see how I organize this, because sometimes kiddos aren't sure if it's a numerator, if it's a denominator, or just what. Let's start with the easy one. Cotangent squared. Do you see here? It's still in the denominator. Like nothing happened to it. Now I can write it separately as 1 over cotangent squared, but I want you to realize that this guy over here, nothing happened to it. Now this one, what I kind of did was I pulled it over, I sort of pulled it off to the side, and I turned it into its own cotangent. And if you're like, where's the fraction? Well, I could write it over 1 if I want to. Okay, there's nothing wrong with that. In fact, we might want to do that. But I want you to see that that cotangent has been kind of extracted and basically turned into a multiplication. Okay, and that's the right way to organize cosine over sine to just be a cotangent. Now, I like that I wrote that over 1 because that helps us now to kind of put this all back together. Okay, and to put it back together is to multiply. And when I multiply, my cotangent, my yellow cotangent, will multiply to the top, and my white cotangent squared, that's going to multiply to the bottom. And I ultimately end up with a cotangent over cotangent squared. Now, if you were looking at the same as Naylor, that's going to cancel. Good. That's going to cancel. That still is simplifying. We're just kind of simplifying this fraction. And you could have canceled this cotangent in the top with one of these cotangents in the bottom. You could have done that the step before if you wanted to. I'm just kind of breaking it down a little bit. And I get 1 over cotangent, okay, because again, the one in the top canceled. 1 over cotangent. Again, maybe it's been a week. That's fine. It's been a week for all of us, but 1 over cotangent, if you look in your little book, 1 over cotangent is equal to tangent. It's equal to tangent. And that would be our most simplified answer. Something that I did, or just something you kind of want to ask about this example? Okay, maybe there'll be a question that comes up at some time. It's fine, because now what we want to do is we want to kind of compare this. I want to compare this with this situation. All right, what do we got here? We've got 1 plus cosecant all over secant. That looks like a lot of fun. I've got 1 plus cosecant all over secant minus cotangent. Remember, I'm trying to show you the different methods to work with fractions. Okay, and this problem is intended for us to discuss the Hart method, which is really the main thing. For you to look at this and say, okay, there's 1 term in the denominator. There's 2 terms in the numerator. Now they are separated with a plus or minus sign, which is why I can do, and I'm even going to say we should do a Hart method. Now, if you're saying, well, what about this cotangent over here? I'm honestly just kind of ignoring it for a moment. And sometimes you just learn a little bit by watching the teacher. Okay, we're just going to ignore that because I want to focus on this Hart method. I want to focus on separating or splitting this fraction to be 1 over secant plus cosecant over secant. Now again, I'm honestly just kind of ignoring that cotangent. Okay, so we used the Hart method because there was a single term in the bottom and there were 2 terms in the numerator separated with a plus and minus sign.
When you do that, is it whatever sign is there you use to separate the thing? So it's...
Yeah, if that had been a minus sign, then we'd throw a minus sign in there. It had to be a plus or a minus sign. If it was a multiplication sign, Riley, if it was multiplication, kind of like this first one, we wouldn't be doing a Hart method. You only use a Hart method when it's plus or minus. Now, I would say there might not be a reason that you would think like this, because this is still new for us. But as your teacher, I want to try to help you to begin to think this way more naturally. And that is when you see these reciprocals, when you see these reciprocals, that you highly consider flipping them. Now, as we talked in some length, I believe last time we were together, when you flip these, you change them. Okay, so when I'm flipping them, they're reciprocal. So cosecant flips down, but it becomes its reciprocal, which is sine. Kind of the same thing with secant. It flips up, but it becomes its reciprocal, it becomes cosine. Now, that's a pretty important step, okay? Because what that does is it starts to help us to see how this problem is going to finish. And this is where I want to just give you guys a chance to notice some things. I have not written down the next step because I just kind of want you to notice. I want you to notice about that cotangent that we were ignoring. That cotangent we were ignoring. Do you see why we were ignoring it? It's now got a partner. It's got a buddy. It's got cosine over sine. Like literally, cosine over sine is cotangent. Okay? These two terms are the same. These two terms are going to subtract to be 0. So we were kind of leaving that cotangent alone because of this step. Now, if you're like, what about this 1 over secant? I didn't forget about it. I didn't forget about 1 over secant. I just wanted you to notice what was going to happen here, and that is that these cotangents will subtract to be 0. Okay, so sometimes it's okay just to leave something alone, to kind of let it alone, and it turns out here that they interact. Now, 1 over secant, there's 2 ways to approach this. Honestly, the easiest way to approach it is to say, wait a minute, 1 over secant, that's in my little book, and 1 over secant is equal to cosine. So just straight up, 1 over secant is equal to cosine. I can kind of like change it, boom, just to cosine. I will have students say that they want to flip it. Okay, if you're one of my kids that are thinking about flipping it, here's what I want you to understand. Secant is going to flip, and it's going to turn into cosine. So there's really 2 ways to think about getting cosine. You can flip it to be cosine, or you can just straight up change 1 over secant to be cosine. It's all the same. We get cosine plus 0. Cosine plus 0. Kind of cut to the chase here, you get cosine. I'm not standing here saying that this is easy, but we also don't want to use as an excuse, that because it's complicated that maybe we're going to try to sort of skip over this. I want you to learn it. Is there anything you want to ask about? I know normally it's when you are asked to do it that we really see, can you do it? I'm going to get you to do a problem, but let me show you another one. Okay, but I have a problem that I want you to do. And that's usually when you really find out, do you get this? Do you get this or not? This is an interesting problem because it doesn't, at least initially, doesn't look like a fraction. It's just secant times cosecant minus tangent. But I thought we were talking about fractions. Okay, well, not every problem is going to scream fraction, when you first see it. This is a problem that as you guys get a little more advanced, you realize that there's fractions embedded in each one of these. Let me kind of help you see the fraction. But you can see it. Secant is 1 over cosine. Cosecant is 1 over sine. Now, just to kind of be honest, but to be nice, as I tell you, I want you to get to know those. Like, the sooner you have those memorized, the more easily you'll be able to work through this chapter. So get those to memory if they're not memorized already. And it's actually the same thing with tangent. It's also a fraction, the sooner you kind of comfortably can say, hey, tangent is equal to sine over cosine. The sooner you can say that, again, the more comfortable you'll be with this chapter. So tangent is sine over cosine. Now, this is a multiplication sign. This is a subtraction sign. I guess what we're trying to say here is let's be careful that we apply them the right way. A multiplication sign is pretty easy to apply. You just multiply the tops. Well, that's 1. And you multiply the bottom. Well, that's just cosine times sine. So basically, when you do a multiplication problem, you just kind of put it all together. All right, and now we get to the sort of the moment that we've been waiting for. Common denominator. Okay, common denominator. Now, remember, I think I mentioned at the beginning of the lesson that a common denominator is when you are adding or subtracting fractions. Okay, this is kind of the first time that we've had to add or subtract a fraction. Okay, the only way to do that is for the denominators to be the same. Now, this denominator contains a cosine and a sine. This denominator only contains a cosine. That means this denominator needs a sine. Let's give it what it needs. Let's give it a sine. Now, if I'm going to give that denominator a sine, I have to also give the numerator a sine. Because the way the story goes is you have to multiply the top and bottom by the same thing. Whenever making a common denominator, you always have to multiply the top and bottom by the same thing. Okay, now this fraction over here is the one that gets a little change. First of all, the denominator is now cosine sine. I'm just kind of giving you a moment to look at the numerator because this is kind of special. Sine times sine, you'd want to write that as sine squared. You want to write that as sine squared. And let's subtract these fractions. Like, this is the whole reason you did this. And honestly, folks, you could skip to this step. You could skip to the step where you write 1 minus sine squared all over the common denominator. Okay, this is why we did this. So we could write this as one fraction. 1 minus sine squared all over the common denominator. Now, the fun's not over, and sometimes students will begin to realize, how do I know when I'm done? That's a good question. How do you know when you're done? Okay, some of it is just from experience. Like, you're watching me do some problems, you're going to do some problems for homework, and you're going to look at this problem someday and you're going to say, I'm not done. Because there's just more identities, like 1 minus sine squared. Again, you got to look in your little book. It would be in the center page. Maybe you're getting to the point that you kind of recognize this. The sooner you recognize this, just again, the more comfortable you get with this chapter. 1 minus sine squared is a Pythagorean identity. Did you find it? It's cosine squared. It's cosine squared. So we're not done because we're able to change that. But again, we're not done because we're able to simplify this. Okay, so as you get more comfortable with these, you'll say, okay, I'm going to cancel these cosines because I can. Okay, so of course, one of the cosines cancels in the numerator, but I'm still left with a cosine. In the denominator, I'm only left with sine. But there'll become a day where you will say, I'm not done. I'm not done because cosine over sine is equal to, now this would be a quotient identity, so it would be near the front of your little book. Cosine over sine is equal to cotangent. That's a good problem. That's kind of my language of saying requires quite a bit of thinking. Okay, I want you someday to get to the point that you can do one of those. If you're like, how am I going to do that on my own? Well, I give you a problem that's kind of like it. Someday you'll see one that's kind of like it. Okay, it'll just have a little bit of kind of like some switches here. Like it's not going to be the exact same problem, but it'll have some of these items switched, but it'll kind of feel the same. This was a key step. 1 minus sine squared equaling cosine squared. That was a key step to be able to change that with Pythagorean. Okay, those are our 3 fraction examples. I just kind of want to throw in here something that's not a fraction, but we have a little bit of space, and I just know it's going to be good for you to see this. It's actually a little bit of a review problem from the last lesson. We've got secant squared times tangent squared plus secant squared. Secant squared times tangent squared plus secant squared. After we do this problem, I'm going to give you a problem to try to do on your own. But let's just talk about this. It's a good review question. I want you to look at this problem and kind of make no other choice but to factor. I'm showing you a factoring problem because I want you to see that this secant squared, it's repeating. And folks, I'm not sure I can think of a time when you wouldn't factor this out. Now, the kind of factoring that I'm talking about is like a GCF. You pull out the common secant squared. Now you'd be left with tangent squared plus 1. Make sure you get that plus 1. Sometimes we end up with like a 0 there, and that wouldn't make sense. So tangent squared plus 1, it's kind of like you're dividing the secant squared. I'm putting a little curly brace under that because, again, as you get more comfortable, you will say, wait a minute, tangent squared plus 1, I recognize that. You look in your little book and you see that it equals secant squared. Equals secant squared. Now look, if you're saying, Miss Naylor, where'd you get that? Make sure that you speak up, okay? Because I'm just assuming that you're looking in your book and you see that. Secant squared times secant squared, okay? You want to look at that and say, there's got to be some way to put those together. Like, you shouldn't stop yet. There should be some way to put them together. Now, if that was secant squared plus secant squared, if it was secant squared plus secant squared, then it would be like that homework problem from the other day where we would get 2 secant squareds. But it's secant squared times secant squared. Thank you. Now, when you're multiplying, you have to think about something that you learned in algebra last year. And that is that you're going to add those exponents. You're going to add the exponents. Again, when you're multiplying, you add them. So we actually end up with secant to the 4th. Be careful, because I'll have kids say, did you multiply those 2's or did you add those 2's? Well, you get a 4 no matter what, but we added the exponents. Now, as you guys become higher level students and maybe thinking about some post-high school studies, and you take notes, which is what I'm trying to teach you to do, consider writing down things beyond what is just written on the board. Like, consider writing down things that I'm saying. I wonder, did you write that down? Did you write down that you add the exponents? Did you kind of feel like that would be helpful? If it's not helpful, don't write it down. But I kind of feel like we could go back through each of these problems and maybe there could be something we could write down. What would it be for you? Again, I put a little star over here, but that was the Pythagorean identity. And again, I'm not going to go through each one of these, but I am going to just sort of ask you, was there something that you thought you could have written down? Do that as we keep learning this year. It's not always just what I put on the board. It might be some things that I say. Okay, I used to have some professors in college that they went pretty fast. So sometimes it was hard just to keep up. I'm going kind of slow, so you have a chance to write down some extra things. Again, if you want to. Now, why don't you try one? Most math students, it's when you get to the point that you have to try it on your own that you really find out, can you do this? We got secant over sine minus sine over cosine. Secant over sine minus sine over cosine. Now, I do want you to get this right, and a lot of that depends on just starting the problem correctly. So I don't want to ruin it and tell you everything, but I do want to get you thinking. I want you to get you started on the right foot here. It's the only thing that you should flip. Okay, now when you flip secant, it now parks down in the bottom and it turns into something new. Wait a minute. This is going to end up being the same problem. It's actually going to end up being the same problem that you guys did. I didn't realize that.
I don't think anybody would have noticed. Yeah. Until you said something.
You would have noticed, though, in the next 30 seconds, probably.
Isn't it one I wasn't catching.
It was going to turn into this example. So instead of kind of wasting time with that, just give me a second here. I want to create another problem that would be a little better experience for you.
I would have done it.
Yeah, sorry about that. I don't know if I ruined it by saying that, but I'd like to give you something new and fresh. All right, this will be an easy switch. All right, take two. It's actually not the same problem that I just erased. It's also not the same problem that we did a few minutes ago. It's cosecant over cosine minus cosine over sine. It does have the same hint. Maybe you didn't need that hint this time, but I still want to tell you that you're going to flip the cosecant. Okay, now, again, I'm going to let you try to work it out, but especially to get this first step correct, as I'm trying to show you, we're only flipping the cosecant. Some of you flipped both. It's not like it's wrong, it's just not going to be helpful. The other thing that some of you are doing is you kind of lost the whole fraction. Like you flipped it, but you don't have it in the denominator. So just take a careful look at what I wrote down. All I did was flip cosecant. If for some reason you didn't have it that way, you can pick up at that step. Now, if you're a little unsure as far as proceeding, this is a common denominator. Has sort of common denominator written all over it. And again, the problem should feel like a problem that we did already. I'm really impressed. You guys are doing a nice job with this. This is part of just the growth. All right, now, again, this is part of growing. Some of you are changing cosine over sine to be cotangent. Once again, that's not wrong. It's just not helpful. You say, why isn't it helpful? Well, it's not helpful because it doesn't allow you to do the common denominator. So if you're changing this to cotangent, I want you to more think about making the denominators the same. So you should feel like that this denominator needs a cosine. So give it what it wants. Give it a cosine. Make sure you give the top a cosine. Now, I know some of you already did this, but I just want to give people a chance to kind of see this through. You're only about one step, maybe 1.5 steps from having this thing simplified. If I can explain something, just ask. You should be changing this to be a cosine squared. Did you feel like you wanted to write this as cosine squared? It's actually 1 minus cosine squared. 1 minus cosine squared. I did kind of skip a step. I skipped showing it as 2 fractions. I just went ahead and put it all together. What's 1 minus cosine squared? What's 1 minus cosine squared? Are you recognizing it as an identity? 1 minus cosine squared is sine squared. Correct, sine squared. Okay, so the numerator turns into sine. And we're ready to do a little bit of canceling and a final identity.
So when you move this CSC to the bottom, do you not have to flip the whole thing?
That's exactly right. See,
So when you want reciprocals, you don't have to flip the whole fraction.
you don't. You can apply, let me use the word apply, the reciprocal to any function you want. It doesn't have to be to the whole thing. Now, Riley, you've seen us flip both before, right? I mean, you've seen us flip both, but this is just an example that you don't have to. I'm getting a sense that you guys realize that these signs cancel, and that leaves us with sine over cosine. But of course, sine over cosine is the same as tangent. Kind of like I said at the beginning of the lesson, we've opened up a can, okay? But it's an important can, so I want you to do your best to try to learn it. The homework helper is another step in trying to learn that, okay? Not every problem in the homework helper is exactly like what I did today, but they're supposed to be similar, okay? So we'll come back tomorrow and we'll start at that point. We're getting closer to the point though where you don't have to listen to me as much, and you'll be able to just practice some problems, which again, I'm going to have you do. But until then,